In this section, we will be implementing feature transformation. In this section, we're going to take a look at dealing with target labels, dealing with correlated data, imputing missing data values using the mean, median, or mode, detecting and removing outliers based on percentiles, and detecting and removing outliers based on median and standard deviation. In this video, we're going to learn how to work with target variables. Specifically, we are going to look at methods to deal with an imbalanced data set. So let's load all of our packages again. And now let's load this new package from scikit-learn that will help us develop a classification report for our model. So sometimes target labels can be problematic. In our case, they are problematic because they are imbalanced. We have a lot more creditable people compared to the not creditable people because that's mainly just how lending works. Lenders are very risk averse and they would much rather miss out on giving a loan to someone than to give a loan to someone who would default. So let's look at methods to best deal with an imbalanced data set. Method number one is don't use accuracy as a metric. Other methods for seeing how well your model is performing are using a confusion matrix, looking at the precision, and looking at the recall. Let's load our cleaned German credit data set. And let's build a baseline model. So the accuracy of this baseline model is 0.72. Our confusion matrix says that 24 defaulters were predicted correctly, and 121 creditable people were predicted correctly. However, we incorrectly predicted that 38 people are creditable when they were actually not creditable. This could be a problem. Now let's look at our classification report. Okay. So in this classification report, we can see what the precision is, what the recall is, what the F1 score is, and what the support is. So recall is equal to true positive divided by the number of true positives and false negatives. Intuitively, it gives us information on the model's ability to find true positives. And precision is equal to true positive divided by true positive plus false positive, which tells us about the ability of the model to correctly label a sample as positive. Method 2 is to resample our data or to use models that resample data like random forests. And method 3 is to collect more data, if possible. So when dealing with an imbalanced data set, the first method you can use is to look at the precision, recall, and confusion matrix. The second method you can use is to resample your data or use a model like random forest that actually builds new data points based on the data points that you give it. Or number 3, which is usually the most challenging method, is to collect more data. So to summarize, in this video, we have gone over the German credit data set. We've looked at an imbalanced data set and how to deal with that imbalance. And the methods that we have discussed on how to deal with the imbalanced data set is to collect more data, choose different performance metrics, or choose models that work well with imbalanced data sets.